Hi everyone, Dr. Schmidt here. We are in section 9.4, and I took the liberty of copy pasting this from your e-text right in here because I really want to emphasize that it is very important that you copy down these Excel functions because they're surprisingly easy to use once you get the hang of them. So if they're a little intimidating at first, I would ask you, please be patient. Let me show you several examples. They're actually really convenient formulas. Couple of words of caution before we start going through some examples. Any money that comes out of your pocket, like a payment to the bank, a retirement account, a deposit, anytime money is coming out of your pocket, you must make it negative. So I'm going to show you many examples of that. The second thing you need to be very careful about is the rate function. This one right here, this rate function. It always gives you the periodic rate, which is not always the same thing as the APR. So if you want the APR, you have to multiply by the number of periods. I'll give you an example. So let's say we had this calculation. We had a rate calculation of 60 payments of $500. So if you're paying $500, it's negative, it's coming out of your pocket. And then we'll put 20,000 here. Maybe we're paying for a $20,000 car loan or something, comma, 0. So if you go back and look at the rate function, I just put these four numbers in here. N per payment, present value, future value. What that does is this will calculate the monthly rate of a 5-year, maybe it's a loan, for maybe $20,000 with a $500 monthly payment. But again, it's a monthly payment. It's the monthly rate. If you want the APR, you would have to take that and multiply by 12, because there are 12 months in a year, to get the APR, the annual percentage rate. So watch out for that. Another thing to notice here, in particular this N per part. So I said that the N per part in the rate function was 60. A lot of students accidentally put 12 there because it's a monthly calculation. It's a monthly rate. But N per is not the number of periods per year. It's the number of periods total. This is your total payment period. So if you're paying every single month for 5 years, that's 12 months times 5 years. Let me write the word months and years to keep that straight. So be very careful with this rate calculation to get APR and this calculation that I'm explaining here when you're working with the N per function. Those are the two most common mistakes. So now we'll get into some more examples. I'm actually going to skip your worksheet examples because I made up several others for you. So what I would ask you to do now is skip number 4 because we are going to use Excel for everything. So when you're doing your MyLab homework, use Excel, please. The formulas are actually much easier to use in Excel than they are to calculate by hand or with a calculator. So use Excel in your MyLab assignments or on your MyLab assignments. Trust me, it will simplify your life. So please, please, please do that, which means you can skip all of this, and we always skip our Excel previews. So let's go back up to the front page, and I'm going to scoot to the left here, or to my right, and I'm going to write out several more examples for you to practice with me. So our first example, let me zoom in so my handwriting is a little neater. How much money must be deposited in an account with monthly compounding and an APR of 4% in order to have $20,000 in 4 years? If, well, I'm going to give you a couple of scenarios. If no additional payments are made. The second condition, so skip a few lines in your notebook, please. The second scenario we'll consider is, what if the same deposit is made each month. So these are our two circumstances. In the first instance, since they asked us how much money must be deposited, and no additional payments will be made, that means we're doing a present value calculation. How much money do we need to put in an account right now? And our interest rate is 4%. It was compounded monthly though. So we have to divide by 12. We will have 4 times 12 in the n per argument because there are 4 times 12 is 48. 4 years and 12 months. And then we will have 0 for our third argument, I'll tell you why in a moment, and 20,000 for our fourth argument. Please notice that this comma in the 20,000 is not in this argument because commas are part of the syntax of an Excel argument. So if you were to put that comma there, it would confuse Excel. So don't write the comma when you're putting numbers into Excel. And then I told you I would tell you where that 0 came from. That's because there are no additional payments made. Now, if you compare contrast what I have here with our formulas up here, we should have a rate, the n per, the payment, and the future value. The rate divided by 12 because it's compounded monthly. The n per, remember the n per is the total number of periods. So 4 years, each 12 payments being made each month is a total of 48, or 4 times 12. And we don't have a payment. There is no payment here because we're just making this initial deposit once and never again. We're just going to put the money in the account and let it grow. And this is our future value. We're trying to save up $20,000. Next, what if that same deposit that we're trying to figure out, we don't know how much we need to deposit, what if we make a deposit every single month? What will that deposit be to achieve this goal? So since that's a payment that we would make each month, you use the payment function, PMT, and we still have the 4% divided by 12. We still have 48 for the n per. This is not changing. We don't have any present value. That's that 0 now. And our future value is 20,000. So now let me color code that a different color and explain this 0, because this 0 is not the same 0 as this one. The reason that blue 0 is there is because if we look at the payment function has a present value and a future value. So not a payment right there. So if we are currently just starting to save up for this $20,000, I don't have any money yet. So this is a PV, present value, not a payment. Okay, that's the difference. When I do this example and I show students a 0 here and a 0 here, they think they're the same 0. They are not. So that's why it's so important, as I was saying at the beginning, that you get these functions copied into this worksheet. They are going to be super helpful. And after you practice using them a little bit, you're going to get really good at it, and it'll be short and sweet and make everything simple. So you can just put those into Excel. I'm not going to put them into Excel just to keep this video short and sweet. The important part is that you know what you have to put in Excel. So let me give you another example. How long will it take to save $100,000? That's a lot. If $4,800 is deposited in an account that pays an APR of 3%, compounded annually this time, if, once again, I have a couple of different scenarios to show you. The first scenario, no additional deposits are made. In that case, if they ask us how long, that's when you need to use the n per function in Excel. That will tell us how many periods, and in this case, the number of periods is exactly the number of years, because this interest is compounded annually. If it were compounded monthly, we would have to multiply by 12. So the n per function would give us Let's see, we have to put the 3% in there. We do not have to divide by anything this time because it's an APR and we're compounding annually. If you wanted to divide by something because you feel like you have to, you could divide by 1 because that's how many times per year this interest is being compounded. Or you can just leave it as 3%. And then our next argument will be 0. Our next argument will be 4,800. And our last argument will be the 100,000. Once again, do not put the comma in the 100,000 number. Now let me explain to you why I put these 4 numbers there. Once again, that's because we have these functions that are super important. Now I'm using the n per function. So we have a rate, a payment, a present value, and a future value. So let's compare that to what I just did. Rate, payment. Payment is 0, just like payment was 0 up here when no additional payments were made. So that's why I put a 0 right there, because no additional deposits are made. This is our present value. Notice it's negative because it's money coming out of our pocket. This is our present value, and this is our goal. This is our future value. So if you put that in Excel, it will give you the n per. I said a moment ago that you might need to multiply by 12. Not in this case, because we're already compounding annually. So in this case, just round up to the nearest whole number. Always round up, even if it would be appropriate to round down. Always round up here. Second part of that question is, what if the same deposit is made each month? Well, then we're still using the n per function. So same function, so we're still using the 3%, but now we have a payment. So I'm not going to have a 0 there anymore. I'm going to have a negative amount because it's coming out of my pocket, so negative 4,800. I don't have any present value yet, and again, we're working towards that goal of $100,000. You'll get there a whole lot faster if you're making monthly deposits. So if you calculate these two things in Excel, which you can or cannot, again, I'm leaving that part out to keep this video short, you'll notice that this first one takes a lot longer, and the second one takes much less time. Once again, you would want to round up to the nearest whole number. You always, always, always round up to the nearest whole number when you're doing these calculations, because you're going to get a decimal number, and if you round down, it just won't be quite enough. You always need to go up to the next compounding period to make sure that you have achieved your goal. You might surpass it, but at least you've achieved it.